GitOpsing Terraform, which was an amazing talk. Everything was amazing. And GitOps, the whole practice of GitOps has continued and it's expanded just since then. It's basically taken off within the DevOps community for the past year, 2 years, and really taken off this, in 2020. So kind of want to go through a lot of those conversations and just have a good convo on chat. So I will be answering questions, so feel free to put any of the questions inside the comment section, and we'll get to all of them. We'll try to get to as many as we can. So let me share my screen. So GitOps, a modern approach to DevOps. So it is basically where the DevOps community has been moving towards within the past few years. And it's been the epitome of what we've been trying to accomplish, from automation to all these new practices, all kind of is leading up to what GitOps has been pushing for the past few years. So for those that don't know me, many of you do. I see a lot of good faces that I recognize, but for those that don't, I am Victor Cuascut, like Alex was saying. I am the director of DevOps for Veeva Systems, specifically for a product called Data Cloud, where we manage hundreds of billions of records and consolidate and try to help out the medical community to kind of build better brands and save lives. It's an amazing thing. And we've been trying to push these brand new technologies. But within there, I've been building out a brand new team, specifically focused on latest technologies. So building brand new stacks from the bottom up, brand new AWS environments, and getting us to a place where we are cutting edge and can build cutting edge technologies to compete with any market that might come up. So by doing that, we focus on GitOps workflows. So what is GitOps? Why should I use it? What is this talk even about within the technology space? So GitOps, in very simple terms, is a way to treat your infrastructure the same way a developer will treat code. You would commit it to a Git repository and store all your information inside a central source of truth, right? Your infrastructure and how you build everything is basically configuration. It's code. It's a way to define what you need and always go back into that single source of truth. So there are a few key GitOps principles that I follow. I think it's the epitome of what GitOps kind of goes towards, right? So the first thing is to describe your entire system declaratively, right? Like I was mentioning, it is a way to put your system as code, define it as configuration, deploy it as configuration, and have a system that actually launches the infrastructure for you, right? No more drift, no more not understanding what's in development, what's in QA, what's in production. It is defined clearly and pushed in, and is versioned, as step 2 says. So now we have a canonical source, a desired state for every single one of your environments. You know exactly what's in there, you know how it was built, and you know how to replicate it. Automatic delivery. So since you have a declarative state, since you know every piece of that infrastructure and how you're going to build it and how you're going to deploy it, now it's very easy to define it and automate it, right? So we have a desired state. Now, how do we actually deploy it? And that's done by using software agents, as on step 4. So now that we have a desired state, how do you make sure nothing actually drifts? How do you make sure An engineer doesn't go in and by hand make some changes. How do you know that a development account is the same as production? So we need a system that also self-corrects. It finds any divergence between what's currently as your declarative source, and then uses software agents to actually implement that into whatever environment you need. So that's great, but why? Why do we care about GitOps? So I specifically looked at a few different options on how we could actually implement it at Veeva. And we chose GitOps for a few simple reasons. We wanted simplicity when it comes to how do we deliver infrastructure, how do we build infrastructure. We had a lot of things that we had to build, and we didn't have a lot of time to get it to market. We needed some way to spin it up and deliver it to market as quickly as possible. As many of you probably have that problem. So it needed to be simple and it needed to be fast. Then I had multiple development groups all over, multi-region, QA development groups, security, that needed to be able to spin up their infrastructures and know what they needed to be done between the different environments. So it had to be reproducible. I didn't want singular sources of truth and people tweak them, and then who knows what gets pushed into the next environment. And I needed to know who makes changes where. So as we are building out the environments, if someone is making a change to an environment that changes the state of that environment, I want to know who made the change, why it was made, and was it approved by a source? So it needed to be auditable. So with that, I went into the GitOps approach. And we leveraged 3 distinct tools for this GitOps approach that I'll go over later on the demo. But these were the grail, the triforce of what we needed to accomplish the Argo workflow. So the GitOps workflow. So one was Argo. So we went through a few different tools to enable us to use the GitOps workflow, and Argo superseded a lot of the other tools like Flux and such in order to move into that direction. Kubernetes, of course, we needed to be easy to be built, we need to be deployable, we need to be scalable, and Kubernetes is the source in order to do that. And we went through a few different methods on leveraging Helm. How do we want to deploy, leveraging standard Kubernetes file. And we went with a tool called Customize. So Customize, we're able to use to define our templates in plain Kubernetes YAML language and orchestrate it in a way to deploy multiple different environments. So with Argo, one of the reasons that we chose Argo was we were able to actually implement a GUI, which was amazing. We're able to, instead of Flux, which I've used in the past, this one had a front-facing GUI that was easy for not only my operations team to understand, but also developers. And go in and see exactly what was deployed in what environment, see what was wrong, is there any issues with any of the deployments, and easily visualize what was happening. And with Customize, like I was mentioning in the past, we were able to take base templates, similar to what you would do with Helm, and define those templates and then patch them. So now we had a set of template that was defined in plain Kubernetes language, Kubernetes YAMLs, automate a patch to those. Let's say we want a different image or a different tag or a service name or whatever it may be, and patch that and output what that deliver would be at the end of it. And that became, that had that light switch that made everything so much simpler as we moved over to the Argo GitOps approach. So what we did was build a single source of truth. Now, this is not the only way to build it. This is the way that I built it, and I felt very simple in the way that I'll go over during the demo. But we defined our infrastructure in a singular repo. So it's not a mono repo per se. So all of our applications are actually stored inside their own poly repo design, their own repos themselves, and our configurations, how it's actually being orchestrated into Kubernetes, is defined inside a K8s manifest type of repo, a singular repository. And we broke it out into 4 distinct components. We broke it out into configurations, specifically Argo configurations. This is how things get deployed. Common services. So if you need a service that's pretty much shared between different environments, ingress controllers, metric servers, external DNSs, things like that, you would put it inside the common services. Then there is the actual applications that you would define for your team, and then the environments themselves. What do you want your environment to actually have? Do you want it to have version 1 of this application? Do you want it to have this service name? Those will be defined inside environments. So very, very simplistic on how this is actually accomplished. So we actually split out the CI and the CD components. So the CI would take the information as you commit it, push it into Git, which will do a standard CI workflow, build out an actual image and store it inside a Docker repository. Now, there is where the distinction then lies. The CD component is not actually deploying the system. What we're doing now is just updating that manifest, the manifest that I spoke about in the last slide, which is inside that singular configuration repository. So we update that manifest with a new Docker version, the Docker tag. And Argo would then take that information, understand that there was a change, and automatically synchronize the other environments. And from there, you could get very, very complicated. So this is a sample of our tool set where we are building unit tests, testing, building multiple environments, releasing and validating end-to-end testing, performance testing, security compliance testing, and eventually getting ourselves onto production. And once you have that type of workflow, you could build multiple environments. Everything is template, everything is simple. You go into multiple different environments very, very simplistically. And I'll show you inside the demo that I'll be going through. We'll be going through this repository. This is a repository that I put together that is a demo set of what I mentioned earlier in the video, which is going through the K8s manifest and deploying it directly into Kubernetes. So I'm going to go through a demo right now. So fingers crossed that everything actually works. But what we're going to do is actually spin up a brand new Kubernetes cluster, get it, install Argo, configure Argo, get ourselves into development, into QA, and into production, full workflow in the next 10 minutes. We'll see. So let me go through here. So within this workflow, the first thing we're going to do is actually spin up the infrastructure. So we need a Kubernetes cluster. So let's, in my case, I'm going to spin up a nice kind cluster, nice and simple for us to set up. So we'll spin up a client cluster, which will take a few seconds to spin up.
Hey, Vic.
Yep.
For us people that don't know, what's a kind cluster?
Good question. So a kind is a way to spin up a Kubernetes cluster locally on your computer, in this case, my Mac, in order to run tests. So in production, you will probably run it inside a cloud environment or even on-prem on an actual server. This way, I'm able to spin up and test different configuration files on my local instance.
Is it spinning up a Minikube?
It's exactly like spinning up a Minikube. In this case, it's kind, which is a service, which I find a little bit easier than Minikube, but it's exactly the same construct.
Awesome, thanks.
Of course. So once we have the cluster currently set up, I will create a new namespace for my argoCD and then change to that namespace. All right. Once we have the namespace created, let's actually install Argo itself. And this you could find all on the README within the inside the README inside the actual repository. Let me just actually get that K in there. Okay. So once that is actually being deployed, you could see, let me spin up K9S, which is an actual great tool if you guys have not used it in the past. It's a CLI GUI interface specifically for Kubernetes in order to visualize what you're doing much easier than just running kubectl commands. And from here, you could see that if I show the pods, is actually spinning up multiple instances within here in order to manage the Argo setup. Let's give that a second to finish up. And there we go. Okay. So once we have this, I didn't set up this cluster to be complicated, so it doesn't have any ingress controllers or such, which you probably should want in order to get this in a production state. But what we'll do is let's look for the service. And it's the Argo server. And let's forward the traffic so we could actually see the GUI interface. And then from there, let's go open up another browser. It doesn't have any certs right now. It's fine. Because this is just a demo. And we have the actual Argo already spun up. Now, by default, you're able to actually define the Argo during the configurations for the password, or you could actually run a command in order to get the one that was spun up during install. So in this case, we have this password. And we have an Argo setup. So as you can see, this is plain vanilla. It has no configurations right now. And what we're going to do is actually configure our application and start spinning up some environments. So what I'm going to do is I'm going to call this Argo Config default and run some policies within here. In this case, you want Argo to manage the full lifecycle. So you want it to delete resources and self-heal if you need to. And we're going to put the repository that I had on the link, which I have a default manifest. And for this one, I typically break out my clusters into different Argos, just so we could have clear visibility of what's happening. But in this case, I'm going to do a all-in-one cluster. And I'll leave everything as default and create. Okay, so that's now pulling the information from Argo, and that was very, very quick. Pulling the information from Markate's manifest and starting to spin up clusters that were defined in there. So as you could see within the actual repository themselves, I broke it out exactly the way that I showed it on the slide. So we do have Argo configurations, which, as you could see over here, is the all-in-one cluster that we chose earlier in order to set that up. And then we have our applications. In this case, we have two sample sites, site 1 and site 2. And we have our environments that we want to spin up. So you could see within the environments, we have QA, we have 2 QA clusters, we have a production cluster and a dev cluster. In this case, it's namespaces for our testing purposes. And it automatically started spinning them up. Now, I told you we're going to get a service, we're going to spin up everything and get a service directly from development all the way into production in the next few minutes. So in this case, our development cluster saw that there was a service already inside the config and started spinning something up inside our development environment. But our other environments have absolutely nothing. In this case, it just created a namespace. So none of the other environments have actually anything. So within the dev stable cluster, we spun up a single app, in this case, sample app. So let's go to our services so we could see how this is actually working. And we could see that we have our service for our sample app. So let's forward this as well so we could see what's happening. Port 9999. And over here, we're able to now see, if we go to localhost port 9999, DevOps Drinks version 1, our site is actually deployed. Right? We want to now the developers has tested the site, they validated that it works inside their dev environment, and we want to start pushing it into different environments. We want to get into QA's hands. We want to, or maybe automated QA's hands in order to start building some workflows. So we would go back into the environment section and enable that version for a QA environment. Let's say pre-prod. So we go inside something called customization.yaml, which is the standard customizations on how things are being read within Kubernetes. And this is a customized construct. And we are going to say we want sample site, which is the actual template is listed up here. And we want to change it to have version 2.0. All right, we tested version 1, everything is valid, but we want to move into 2.0 for QA. All right, so if we go in and now commit this change, also commit the README stuff that I put in earlier, hit push. Now push. Since everything was pushed, everything is defined inside Kubernetes. Everything is managed by Kubernetes. Of course, we should did a good PR and been good engineers, but we're just going to go straight through it. So now that we push this into Kubernetes, now that we push this into Argo, into our Git repository, Argo now understands that there's a change inside our QA environment. So this will automatically just sync, but we're going to push it because it takes like 30 seconds to a minute. And we're going to synchronize. It's going to automatically see that there was a change inside the configurations and deploy it. It knows all the templates and knows exactly what version that we were deployed. It's exactly what was in the other environment and starts pushing those new versions. And as you could see, if we go into Kubernetes, now we go into the new namespace, we're now able to see inside pre-prod that we have an actual running version. If we go to services, we will able to see that we actually have a running Docker with a front-facing service. So let's go to 1111. and test that this is actually good. So now we have our DevOps and drinks. Let's go to localhost 1111 and actually see that version 2.0 actually got delivered into QA for validation and testing. So once we are through, let's QA validated everything, all the automated tests were successful. Let's start pushing this into production. And since we already have a standard version, a Docker version, and already have a template, it should be as easy as enabling this inside our configurations. In this case, let's do 2.0. Let's commit, push. So now we updated our configuration. This is typically done via CI/CD, but we've updated our configurations inside Git. And now let's see if Argo could pick it up. So this was a production change. It's going to force a sync to make this faster. But we see that it actually found the change and started synchronizing and making the actual state of the Kubernetes exactly what's inside the Git repository. So now we've got an application from development all the way into production with just a few clicks into our Git repository. And that's great, but having one application is simple, right? Developers now want to test a new service. So if we go back into our development cluster, they want to now enable sample site 2. They want to figure out how to get this into validation and testing. So we would enable this cluster, which was already defined up in the template, and commit our change. So now we should see inside our development cluster, not only one site, which hasn't synced just yet, but we should get a second site also set up with all the additional Kubernetes resources, all the services, any config maps, any secrets that might live within that environment. And as you can see, it's spinning up our secondary site and it's done. And now if we go back to our services and we look for our dev stable, we see site 1 and site 2. So let's forward this one. 2222. And not only did we deploy a singular service all the way to production, but also got a secondary service. And this is a picture of actually my very first DevOps and Drinks with a Verity team. It was amazing, and this group was awesome. Looking forward to when we could actually all meet in person again. But as you can see, we got all the way into production, not only one application, but also started a whole new workflow inside a secondary application. And from there, thank you.
Vic, thank you so much. Vic is notoriously awesome at demos. We did have a couple of questions that came up. I can read them to you, and then
please, go for it.
Whoever has any follow-ups. Is there an official Helm chart to deploy Argo?
Yes, yes. So there is an official Helm chart that deploys Argo. You could find it inside the argoCD site themselves and kind of go through it. And Argo also manages Helm. So you don't have to choose between Helm. If you already have an infrastructure that builds out Helm charts, you do not have to choose between customize and or Helm. It works just as well with Helm as well and deploys it just as efficiently.
Nice. Another one here. Can you tell us 3 things that made that GUI so useful and insightful to you and your DevOps team? Murat had that question. Murat, any want to get specific here?
Well, it's always a question to people that are working with the solution. What grabs you? What makes you like really excited that you're getting a wow moment when you've got a GUI that gives you reveals the truth.
And that's exactly it. It was that wow moment. Again, I've spun up Flux and stuff in the past, and that's amazing to see things that you commit and deploy. And Flux has become much better within the years. It's actually very comparable to Argo right now when it comes to delivery. But that GUI was the changer. When it comes to giving a tool to your developers for them to understand, and maybe they don't really understand Kubernetes, they don't know how to run kubectl commands to actually see what's happening. Visually seeing a deployment happen in real time, understanding what resources are actually being deployed was a game changer for our development teams. And they were able to pick that up very, very quickly.
Nice. I got another one here. How do you deal with secrets within your repo?
Secrets. Secrets is very good. So we leverage it in a few different ways. Again, secrets should never be inside your configurations. It should be externalized using 12-factor apps type of stuff. So I'll tell you how I do it, but there's a few good different ways, right? Benami and seal secrets and such. But we kind of store things inside many different AWS resources like parameter stores or vaults, and then pull them into the application apart from Kubernetes themselves. But we do leverage config maps and such inside the same manner as argoCD. So config map is just a secondary resources. So for configurations are all getting pulled in as config maps, and secrets are currently done external to Kubernetes.
Nice. Got a lot of questions, a lot of participation. Thanks, everybody. Next one, can Argo support the order of how multiple apps get deployed by defining dependencies?
Yes. So there is a synchronization order that you could actually set in a config when you set up the Argo. I typically do not like that method in general. I like that the application would know when it should be live or not by doing health checks. So I would actually push towards the health checks, understanding the order of operations, let everything spin up, let things fail until all the subsequent services are up, and then everything then just turns live.
Nice. Got another one from Paul here. How do you notify after each deploy, since there's a slight lag between commit and Argo autosync?
So Argo does have a integration with Slack. So we currently have it directly integrated with Slack and pushed, but the timing is within a minute on how that happens. So by the time somebody actually knows what's happening, it was very clear during the demo, and I wanted to force the sync because I wanted to make it faster, but it's typically relatively fast. But then I do get notifications via Slack message whenever there's an error or we need to do something specifically with the Argo config.
Nice. We've got a multi-tiered question here. How do developers get fast feedback when testing different configurations for their applications within your clusters? Let's start with that, and then I'll get to the next two.
Good question. So when you do build a service, you are able to deploy it into any environment that you want. So we could actually, I do break up production versus staging / development repos completely separate because I want to keep more management around the production case manifest repos. And our development environment, I actually give a lot more responsibility for developers to control and manage. They understand Kubernetes resources and would manage that. So they would go in, push their changes, understand if a service breaks by enabling a service or disabling a service, and they could even point it to their own cluster. Remember, it's not what Argo sees. Argo is just reading a repository. So they could run all these configurations by themselves inside their own cluster, like I did with Kind, and understand their feedback relatively quickly.
Do they have to keep committing to Git?
So in this case, you would have to commit to Git. Everything is a Git source. Argo doesn't understand anything local. It's a Git, it just fetches from Git. So you would have to commit to Git. But in this case, it's a feature branch. Right? You don't have to keep committing to master in order to understand this. So it would be like somebody understanding their code and committing into a feature branch in order to implement it in the infrastructure they want.
Nice. And the questions keep popping in here. What's the best way to monitor Argo pipelines? Does it support any integration with Prometheus?
Good question. I actually don't know. I don't have that implementation. Right now, I look through logs and I get notifications through Slack. So there is an Argo notification service that you could add onto it. There's a whole suite of Argo tools when you go into the Helm chart. And Argo notification is the way that people are using notifications. And my guess is there are more integrations with metrics. I just have not implemented it currently.
All right, I got another one here. How do you deal with existing / legacy assets that weren't originally deployed with GitOps?
Good question. And then this is where customization comes into place, right? So when you are deploying with Helm, right now you don't really know what's actually deployed, right? You have a whole bunch of Helm charts, then you actually have your actual Kubernetes cluster. What I did initially, again, I had the luxury of starting from scratch, which is a lot different. But what I would do is actually pull the templates directly out of Kubernetes. So this is the actual state, and then use customize to tweak them, to variabilize them, to make them into a template, and then use that inside Argo. With that method, you could kind of keep your state as is, and then let Argo start managing it going forward.
Nice. Anybody have any other questions? Free for all. Unmute yourself. Feel free to ask Vic, or else you get to hear more guitar playing songs that you probably don't like. I'm just saying.
All right, DevOps Drinks. So I'm gonna have a mid-lunch drink while we talk.
All right, I got a question.
And roll. Yes.
Go for it.
What if your application requires like something like a cloud resource, like an S3 bucket or an RDS instance? How am I supposed to coordinate between those two things?
That is an amazing question, and something that I would do inside the next DevOps Drinks if you ever bring me back on. So there's two methods here. There's leveraging Terraform, which is my preferred method, right? I love Terraform. Actually, my last GitOps talk was GitOps in Terraform, but I did it in a very specific way that was managed a few years ago. Darren, I think you know all about that one. But the cluster, the way that we would push it going forward is actually leveraging Terraform operators inside Argo themselves. So now it's just a Kubernetes resource. We're able to push it and we're able to launch everything that you need, just like any other Kubernetes resource.
That's yeah. I think HashiCorp just came out with their official operator, right, recently. But here's a question. So obviously the resource, let's say it's an RDS instance, and there's like a database password that exists. Is there any sort of race condition between RDS existing, making this like password available, and then mapping that password into my deployment? Is there any problem with that happening, or is it just all seamless, everything works great?
Good. So the way that, again, I use externalized secrets. So let's say I have a Terraform that would launch a RDS instance. The RDS instance would then create the resource, take that password and store it into, say, a vault or a secret store of some kind. And then the other resources will actually keep failing until it gets that password, whatever it may be. But once it gets the password, it should then start up. Now, the race condition, you should not have failures because of race condition inside Kubernetes. So if you follow that path and you have proper health checks, it should work.
Awesome, thank you.
Of course.
Any more questions? All right, so a couple of quick notes. Vic, thank you very, very much for the time you took for the presentation, for the demo, for helping educate us. Vic isn't going to say it, but I will. Even though he can't use me, he is hiring, and he needs people. I don't want to say it, but I'm gonna, because Vic's awesome. Yeah. But yes, Vic is hiring.
And if I could use you, I would. Trust me.
I know.
You know, I've always used you in the past.
That's the love. But yes, Vic is indeed hiring. So if you guys are interested, hit him up online. And if you guys are interested in anything that my team can help you with, we've got Danny on here, we've got Chad on here. We are here to help. And we're really grateful that you guys decided to spend your Friday afternoon with us. So I hope you have a great one. I'm going to play some outro music for you. And next time you get a LinkedIn message from a Verity, hesitate a second before you delete it. Say what's up. Say hi. You don't need to be looking for a job to be friendly with a recruiter. I promise. So, on that note, have a great day. I'm going to hang out as long as you guys want. I'm going to play some tunes for you.
Thank you, everybody.
Vic, thanks, man. I gotta practice. Have a great day. Go back to work, people. Come on. No, for real. Thanks, everybody. Have a great one.
Thank you, Alex, for inviting such a great event.
Thank you. More coming. Hey.
My son.
Hey, bud.
It was my first time. I really enjoyed. Thanks for inviting.